Hello, and welcome to Lesson 4 of B.3, the Cancer Unit. I'm Nicole Bettis, an OpenSciEd facilitator and former high school biology teacher. In this video, I will give an overview of Lesson 4 and wrap up with some tips and tricks. Lesson 4 contains my favorite computer simulation, and hopefully by the end of this video, you'll see why. Before we jump into Lesson 4, let's briefly recap how we got here. During Lesson 3, we figured out that cells go through a cell cycle that ends in cell division. When this cycle isn't properly regulated, it can result in the formation of cancer cells, which have differences in their chromosomes. We remember from Lesson 1 that some types of cancer are more common than other types, and that older and taller people are more likely to get cancer. So now we're wondering if maybe there's a connection between these things and the cell cycle, and we want to investigate why some kinds of cancers are more common than others in older and taller people. Now for Lesson 4. Lesson 4 takes one class period. It involves using a computer simulation to investigate different rates of cancer. The 20 minutes of material preparation listed here is to make copies of handouts. Because we are using a computer simulation, students will need their individual devices. The teacher edition suggests one device per pair of students, but my students enjoyed running their own simulations on their own devices. Lesson 4 begins with students developing and sharing initial models to show their current thinking of how the cell cycle and cell division can lead to different rates of cancer for older and taller people. Then they use the cell growth and cancer computer simulation to investigate this. After the simulation, students answer questions to help them make sense of their results. This is followed by a building understandings discussion about cell division, mutation rates, cell types, and cancer, after which students revise their initial models and update their progress trackers. Through all of this, students figure out that the chance for mutations increases with the number of cell divisions. Overall, in Lesson 4, students figure out that some types of cells divide more than others, that the longer you live, the more your cells divide, and that the taller you are, the more cells you have, so the more your cells divide. They also figure out that the more cells divide, the more chances there are for mutations to happen. Let's take a look at two key moments in Lesson 4. One key moment comes in Part 3, when students use the cell growth and cancer computer simulation to investigate the relationships between cell types, cell division, height, and age. The simulation tracks the number of mutations in 5 different types of cells as they go through cell division. When there are too many mutations, the cells become cancerous and the simulation detects a tumor and stops. One of my favorite moments with this simulation comes at the beginning when students adjust the height and see what happens to the number of cells. They notice that taller people have more blood, colon, and skin cells, but the number of brain cells stays the same. My next favorite moment is when they start the simulation and realize that the brain cells don't divide very quickly. This leads to some fun conversations about the brain. Students are instructed to run the simulation until a tumor or age 90 is reached. If a tumor results, then they keep track of the age at which it was reached and the biopsy results. The simulation will indicate the cell type and whether the biopsy was positive or negative. My students enjoyed playing the simulation over and over again, trying to get cancer. The more they run the simulation, the more they realize that cancer happens over time as mutations build up, and that mutations build up more quickly in cells that divide more quickly. This really helps students visualize the time component of cancer and understand the reason some cancers spread quickly while others don't. At the end of the simulation, students answer the making sense questions in their handout while you gather the class data. After completing the questions on the handout and gathering class data from the simulation, students make sense of the simulation through a building understandings discussion. This discussion provides an opportunity for students who didn't get cancer in the simulation to hear about it from students who did. It also provides an opportunity to emphasize the graph showing the relationship between the number of cell divisions and the average number of mutations per cell. It is important to make sure that mutations are called out in this lesson because the next 2 lessons will focus on mutations. By the end of this lesson, students have figured out that some types of cancer are more common than others because some cells divide more frequently than others, and that taller and older people are at a higher risk of cancer because they have more cell divisions. They know that when the number of cell divisions increases, the average number of mutations per cell also increases. However, they don't know why this is happening, so they will investigate the relationship between mutations and cell division in Lesson 5. Before I sign off, I want to leave you with a few tips and tricks for Lesson 4. First, I recommend trying out the computer simulation ahead of time so you know it works with your students' devices and you're familiar with it. Second, the simulation shows height in centimeters. My students struggled to make sense of this, so I set up a marked piece of masking tape near the door and had them measure themselves on the way in. This way, my students could run the simulation with their own height if they wanted to. While students were running the simulation, I heard a lot of talk and even a few questions about moving cells. At first, I was confused by what they were talking about. Then I realized that the way the simulation shows mitosis makes it look like the cells are moving. I explained to students that when a cell dies, one of the surrounding cells will divide to fill in the empty space. So what looks like movement is really a new cell being formed. Finally, have colored pens, pencils, or markers available for students to use when they draw the graph on their handout, and collect the class data while they're answering the questions at the end of the handout. The class data table in the slides has space for 6 groups, but with students working in partners, I had way more than 6 groups. Since most students made it to age 90 without cancer, I just asked the ones who did get cancer to share the age and biopsy results. The purpose of the class data table is to look for patterns in the age and types of cancer, so you only need data for those students who got cancer. When looking at the guidance for developing your personal glossaries in the unit overview materials, there are 4 words shown under words with meanings we co-construct. Of those 4 words, mutation is the only word that students actually encounter in Lesson 4. The rest of the words, as well as the word mutation, are encountered in Lesson 5. Since there are no slides in the slide deck for updating personal glossaries in Lesson 4, you can take a moment to add mutations to their personal glossaries in this lesson, or you can wait until Lesson 5 after they learn more about mutations. I would recommend waiting until Lesson 5 when students encounter them to add the other words to their personal glossaries. Finally, you won't be creating any new posters in this lesson. You will be referring to the initial class consensus model at the beginning of this lesson as you navigate in, so you might want to have it in a visible place for students. And students will be updating their progress trackers at the end of the lesson. In summary, Lesson 4 is all about figuring out that some cancers are more common than others, and some people are at a higher risk of cancer because there are more cell divisions and therefore more mutations in their cells. In the next video, I will be talking about the Lesson 5 DNA replication fork simulation, which will help students figure out why more cell divisions leads to more mutations. So be sure to check it out.